their own process.
All right, so there's two big domain restrictions that we're going to look at. The first one is your troublemakers. You cannot divide by what? Zero. You cannot divide by zero. So the big one is your troublemakers. Who is getting booted out? When you set up a problem involving that, you use this symbol, which means not equal to. So you're saying we cannot equal whatever this is. Go ahead.
Does the slash have to be that way?
No, it can be either way. So here, I'll just, as a side problem, and you don't have to write this part down, I'm just going to grab a sticky note and I'll just show you. For example, just watch. Just for example, give me some single digit numbers. I'll make something up.
3.
Okay, so your denominator, 2x minus 9, is not allowed to equal 0. And then, like, welcome back to Algebra 1, you would just solve that. What would you do?
Plus 9.
Yeah, plus 9 divided by 2. Your troublemaker is 9 halves. Do you see what I'm saying?
Yeah.
Okay, and then you would write negative infinity to 9 halves, union 9 halves to infinity. Cool? Right, okay. Perfect. That's all that means. All right. And then the second one is you cannot square root a negative. And actually, I say square root there because we're going to just do square roots. But it's any even root. So like a 4th root, a 6th root, an 8th root. Do you get what I'm saying there? Like any of the even roots, you can't have a negative underneath of them. I just wrote square root because that's like mostly the ones we're going to do. And so the symbol you would use for those is greater than or equal to. You need to stay bigger than 0. 0 is okay, though. You can equal it. What's the square root of 0? 0. You just can't square root negative. So here, just watch. I'll do a real quick example of something like that. Again, give me some single digit numbers and we'll make something up. So here's like 5. So 5x minus 2. Okay. You can't square root a negative. So you would say 5x minus 2 has to be bigger than 0. And then you would solve that. So what would you do?
Plus 2.
Yeah, plus 2 divide by 5. And you would, now this one, you would have a bracket or a parenthesis? A bracket. So it would be 2/5 to infinity is like how you would write that. Cool? Those are your two main rules. You can't divide by 0 and you can't, I wrote square root, but you can't even root a negative. So those are like the two main big rules. So when you do a combined function, and then combined meant that you add, subtracted, multiplied, or divided, you just combine the two domains. And I'm going to show you what I mean. But basically, you just put them together is all that it is. So please don't overthink this. You just put the two together. So what we're going to do is write the domains of each of them, and then we'll put them together. So looking at this first one, f of x, do you see how that's squared? What does a squared graph look like? A parabola. What's the domain of every parabola? Yeah, everything, right? All reals. Okay, isn't that great? Now this one, you can work out a problem like I showed you on here, but we're going to do enough of these and it's so basic. I'm going to coach you to try and like just jump to the answer. Or you could think of this graph moved right 5. Do you get what I'm saying? Like with your transformations. But anyway, it's going to be bracket 5 to infinity. You want 5 and numbers bigger. Give me a number bigger than 5. I'll show you. So 6 minus 5 is 1. Can you square root 1? Yeah. 7 minus 5 is 2. Can you square root 2? You can. It's a weird decimal. Give me a number smaller than 5, though. Like something that'd be... Yeah, so like 3 minus 5 is -2. Can you square root -2? Actually, you can. It would be imaginary, but, you know, when we're doing domain, we don't do imaginary numbers. So if you put these together, this one's everything, so we kind of don't even use that. Your domain for both of them together would just be 5 to infinity. Because this one doesn't have a restriction. So you just follow this one's rule. You'd have to follow both of their rules at the same time. Like, for example, say you're talking about dress code. I don't know. I'm just making something up totally. If this guy said you're not allowed to wear red and this guy said you're not allowed to wear blue, then together you would not be allowed to wear red or blue. Do you get what I'm saying? But this one said you can wear whatever you want. So we kind of ignored that one. Do you get what I'm saying? Like you kind of just ignored it. All right, this one. Who is your troublemaker? 9. We're going to boot out 9. Now this, what would it look like if you graphed 7x plus 4? This is y equals mx plus b here. It's what? It would start at 4 and you would go up 7 over 1, but that's a more complicated answer than I was looking for. Just what shape is it? A line. There we go. A line has a domain of everything, all reals. Yep. Goes forever in both directions. So if you combine those together, yeah, it would just be the left one. Because this one doesn't have a restriction. So it's kind of like whatever. It doesn't have a rule. Now this one, they both have one. So you'll see what happens when they both have one. Who's the troublemaker of it? -2. We're going to kick out -2. -2 is causing problems. Oh, yeah, go ahead.
Why do we bracket some numbers and then not bracket?
I'm glad you asked that. Let me write the answer to this one and then we'll talk about it. So this would be bracket. What do you think? I just want you to give it a guess and I'll tell you. Good. Or you could think of it went left 5, or you could think of setting up a problem. X plus 5 is greater than or equal to 0. If you solved that, you would subtract 5. So the reason this one gets a bracket is this. Look at, if you plug in -5, what is -5 plus 5? 0, and you can square root 0, it's 0. So that's allowable. If you plug -2 in here, you get a 0 denominator, which is not allowable. So these indicate we're leaving it out. This indicates we're keeping it. Now, when we do both of them at the same time, this one says you need -5 and above. This one says you need to leave out -2. So if you do them both at the same time, you want -5 onwards, but also leave out -2. So do you see how you're doing both at the same time? So it's both rules at once. It's kind of hard to see that when one of them is all reals. When we get to ones where they both have a restriction, then you can kind of see that a little bit better. So let's try this one. Who's your troublemaker for f of x? 6. Leave out 6. And then this one would be bracket starting where? Yeah, -1 onwards. Yep. So -1 and everything above will keep a positive number underneath that square root. So if you combine those together, it's like you're following both rules at the same time. It would be -1 to 6, 6 to infinity. Good job. So that's just combining them together. Go ahead.
Like I see that on every time we had a square root, that's kind of like the only time we bracketed. So is that like the only time?
Yep, because these are your restrictions. If you, and I wrote square root again, it would be an even root. It's greater than or equal to, so you get a bracket on that. Here we want not equal to, so we're leaving out a number. Actually, let's go ahead and put that in the notes too. So if you're leaving a number out, you want parentheses. If you want greater than or equal to, you want brackets. We'll go a little bit further and then we'll do our halfway break. We can get a little bit more done here.
I love them.
Can you go back?
Oh, yeah, sorry.
Not thinking
I got it.
Oh, you got it? Okay.
You're good.
Yeah, it's about like the wrong way.
Yeah, I'm going to do a little bit more and then we'll do a break. Okay, so that was just combining them together. If you just added the functions together or whatever. Composite is f of g. It's like f got hungry and ate function g. You're plugging one into the other. So I always start with a picture for this. So we're going to draw a circle. We're going to plug in x's. I'm going to draw another circle. I'm going to call it g of x. If you do function g, that links them together. It's like a function machine. So if I take all of my x's and plug them into function g, I get g of x back out. So,
G up top by the arrow.
g, yep, g by the arrow. So if you plug in x's to function g, you get g of x. Cool. Input, output. So this is the domain of g, and this is the range of g. And that always goes, well, that's fine. It's when we put a second function in there that stuff gets a little complicated.
That could happen.
And this is, you didn't learn this last year. This is going to be brand new to you, which is why if you look through, you're like, why are there so many examples? First of all, because they don't really involve that much work. It won't take that long. And secondly, we need to do a bunch of them because you've never seen this before. So if you now take that, do you remember telephone game last time?
Yeah.
Where you take this new output and pass it along to the next function. So the next function is going to be function f. And what do you get out of that? F of g of x. Good.
Oh, I thought you said so.
Hey, Miss Cole, when are we gonna use Z coordinate?
We're not.
When do they use Z coordinate?
Calculus 3.
Oh, that in college.
Yeah.
Wait, what?
Have to
That's
remember.
exciting.
So this would be the domain of f, and this would be the range of f. So where it gets sticky is where these have to, you know, kind of match up with each other. Do you get what I'm saying there? This is, and so that's why I drew you a picture, because a visual helps. But this is where it gets a little sticky. All right. So to find the domain of f of g, number one, if the inside function, which if we're talking about f of g, which one is the inside? G. But I said inside, not G, because what if it was the other way around? What if we were doing G of F? Do you know what But what if I changed the letters entirely and it was H of J? You know, I tell my AP calculus students this all the time. Don't get hung up on the letter of the alphabet, okay? Because you could call them whatever you wanted, right? If the inside function has a restriction, and by restriction, I mean it's not all reals. There was some sort of rule that had to be followed. The inside function has a restriction, you keep it. And that usually goes okay, because you just look at the inside function. If that has a rule, keep it. Okay, fine. That's usually all right. The second rule is where you sometimes have to set up a problem to work out. If the outside function has a restriction, the inside one has to comply. And when I use the word comply, what do I mean by that? What does it mean if you comply with something? Or you follow the rules, right? Like you follow the rules. If you're complying with the policy, you're following the policy. So if the outside function has a restriction, the inside function, must comply. I wrote that a little weird. Let me fix that. So that's where you sometimes have to set up a problem to work out. That's where like the quote unquote work comes into these, where you may have to like do a little work. Let's just try 5 and 6. We'll just finish up this page and then I'll give you your halfway break, right? So first let's do our domains of each of these. What would this one look like? It's squared, so a parabola, a U shape, and that would be everything. Yeah, parabola is a really weird word. This one would look like what? Yeah, a line, so everything. I'm starting out with a really easy one for you, okay? Actually, this problem is basically just a review of what we did last time, because here, I'll go ahead and do the domains. If these are both all reals, for your composite functions, what do you think these are going to be? Yeah, all reals. If there weren't any restrictions in the first place, there's not going to be any restrictions here. So basically, this question is just a review of last time, which is fine. It's like an extra warm-up. Which function gets plugged into which here? G into F. So we're going to take this x minus 5. It gets plugged in over here. So I left a little bit of space. You're going to have 3. Now it would be x minus 5 squared, but I have coached you to just write it twice. That's what squared means. And then tacked on at the end of that is a +4. And then you have the slightly tedious job of distributing that together, but you guys have done really well with that. I'm not worried about this step. I think you're going to be okay. It would be x squared and then what? Yeah, minus 10x. Good. Plus 25. And then I'm going to go ahead and write my final answer on the line there. You would just distribute the 3 and combine like terms. So it would be 3x squared minus 30x. Now it would be plus 75 plus 4, so plus 79. Again, that's just a review of what we did last class.
Yeah, I love this.
Yeah, those are fine. I like them too because I feel like it's easy money on a test, you know? Now this one, F gets plugged into G. So now this entire thing gets plugged in over here. So you're going to have all of this. And if you can do this in your head, I'm even fine with you skipping writing that step. If you can do that in your head, that's allowable because that's a simple thing. But it's all of this gets plugged in for X and then minus 5. So all you'd have to do is put these like terms together, be 3x squared minus 1. We don't factor those. We don't set them equal to 0. We don't solve them. That's your answer. Okay. So now we'll do one that actually has a restriction. This one is a parabola. It'll be everything. This one has a restriction. Bracket -4 and above. Kind of like you have to be this tall to ride the ride. You need -4 or bigger. Okay. So now this is going to involve like some actual thinking. When you do f of g, g gets plugged into f. So this gets plugged in over here. It would look like this. And we had this conversation last time about does it cancel or hands off? You know, sometimes you just have to do nothing. Does this cancel or not? Why does it cancel? Because it does. It's the whole thing. Good job. Perfect. So it's just x plus 4. Now here's where this is new. Which one's the inside function, f or g? G. Does G have a restriction?
No.
Yes, it's not all real. So if G has a restriction, keep it. Okay, so we're going to keep this. Now, does the outside is F, does F have a restriction? No, so that's step 2, we can skip this. We don't have to set up another problem. Do you get what I'm saying there? Like we don't have to do this part. All we have to do is keep this one. So if the inside function has a restriction, keep it. Hey, Miss Cole, it looks like you just copied that over. Sure did. Like if the inside one has a rule, like it's not -infinity to +infinity, then you just keep it. If the outside one has a restriction, that's where you might have to do some work. But our outside one didn't have any kind of rule, so we were just done. All right, let's try it the other way around. This time F gets plugged into G. So this x squared gets plugged in over here. Now you can probably tell because I wrote the answer on the line, but is anything going to cancel there? No, why not? Not the whole thing is squared. The squared is only on the x. Okay, domain. Which one is now the inside? F. Does F have a restriction? No. Okay, great. Step 1, done. There's no rule. Step 2, the outside one is G. Does G have a restriction? This is how it works then. Hey, f of x, you better stay bigger than -4 or else no dessert. Do you get what I'm saying? It's like, hey, you have to comply with this. So it's, hey, f of x, which is this. Hey, f of x, you better stay bigger than -4. And that's why I stress those symbols on the other side of the paper because everybody's always like, which symbol do I use? Hey, you better stay bigger than -4. And then you just see what happens. People try to force these problems to turn out a certain way because they have some kind of preconceived notion. You just do it and see what you get. What would you do to maybe try and start solving this? Or what would you try to do next? You would try to square root. Now, if you go to square root, you can't square root a negative. What that means is this. It is already in compliance. And the analogy I use for that is when your mom or dad comes in and they're like, do your homework. And you're like, I already did it. It's all done. Geez, like I already did. You get what I'm saying? Like it's already in compliance. Okay. So your domain ends up being all reals. It's like, I'm already following the rule. Geez, leave me alone. Is that making sense? Like, do you get what I'm saying? Like this didn't take us anywhere. It's already following the rules. So we're already good. That's why we're going to do a whole mess more examples. So looking at this one, what is going to be our domain for f of x? Yep, 9 to infinity with a bracket. It's like you have to be this tall to ride the ride, greater than or equal to 9. This is a parabola, so that's going to be all reals. So when you do f of g, g gets plugged into f. So you're going to take this g of x over here, gets substituted in for x right there. It is not going to cancel, just hands off. Don't do anything because the squared is not over everything. It's only on the x. Now here's the domain. Which one is inside? G. G is right here. You kind of have to watch me point to this because there's not a whole lot of work that happens. You just kind of talk your way through it. Does G have a restriction? Great. Step 1, done. It's everything. Step 2, the outside function is f. Does f have a restriction?
Yeah.
That's where you have to set up a problem. Hey, g of x. And g of x is this right here. Hey, g of x, you better stay bigger than 9 or else.
But it's not, right?
Hold on a second. I'm not there yet. I'm just showing everybody how to set it up. Hey, g of x, you better stay bigger than 9. You have to be this tall to ride the ride. You better be taller than 9 or you don't get to ride. Okay? Then you don't have any preconceived notion. You just see what happens. What would you try to do to both sides? Right now, this one's going to work. We're going to actually get an answer. Your square root of 9 is 3, but it is also it's plus or minus 3. So here's how it gets written. X is greater than or equal to 3. When you do the negative 3, what do you do to your little alligator mouth? Yeah, turn it the other way. So here is how that's going to look when you write your answer. It's going to be negative infinity to negative 3, the bracket, because we have equal to's on these, union 3 to infinity. And I will draw a little picture and show you what these graphs look like because I think they're actually very cute and it helps everybody remember how to write it. If you were to graph this right here, this is what it would look like. You would have a point at positive 3, you would have a point at negative 3, and it looks like this. And I always say they look like little alien antenna. It's a cute little graph. Anyway, that's what it looks like if that helps you remember how to write it. It's neat. All right, for this one, which function gets plugged into which?
F.
Good. This is going to get plugged in over here. You're going to have square root of x minus 9 squared, which is just going to give you x minus 9. And if you're getting to the point where you can visualize that, I'm fine with you not writing this part. That's okay. If you're at that point where you can do that in your head, because that's a simple thing and I'm fine with that. So which one is inside? Does F have a restriction? That means you keep it. That was step 1. Keep that. Does G have a restriction? No. So you don't need to set up a problem. All you do is copy this over and that's your answer. So step 1, if the inside one has a rule, you keep it. Please stop humming. If the outside one, sorry, just distracting me. If the outside one has a restriction, that's where you have to like do work. All right, number 8, what do you think for domain?
It's not even 0.
We are not going to equal 0. 0 is a troublemaker, boot them out.
So we don't wrap.
Correct, because you're kicking it out. Yeah. And then how about this one? All reals. It's a line, linear, all reals. All right, f of g. G gets plugged into f. So you're going to take this x plus 3, plug it in right there. It's going to look like this. You can't, yeah, hands off. A lot of these you just do nothing. For this one, oh, here, let me do the domain for that first. What I would honestly do for this is just go, hey, what's the troublemaker? I wouldn't even go through the rules, to be honest with you, because you guys have done this a million times. Who's your troublemaker for this? Yeah, so to be really honest, I wouldn't even try to go through those rules. You know how to do that. You've been doing that. You're good at it. Just do the problem that way is my suggestion.
Aren't those just right? Like x doesn't equal negative 3.
We use interval notation in advanced math. That is called set notation. We use interval. All right, this one, f gets plugged into g. So this 1 over x gets plugged in over here. So it will be very subtle, but different. These are different things. Because who is your troublemaker for this one?
0.
0. And that's basically like if the inside function has a restriction, you keep it. We just kept that, but it's because 0 is still the problem. I'm the problem, it's me. 0. Like that's who you've got to kick out.
So how are you able to just do that because like the ones that would cancel, like the ones that would make it 0, like are the things that like don't comply?
Yeah.
Okay.
Yeah. Is that a song?
No.
Oh, I didn't know that. No.
Oh, it's probably not.
All right, what's your domain for this one?
it-
1, 2.
It can equal 1, but yeah, 1 or above. It's like you have to be this tall to ride the ride. 1 or above. This is a parabola, so everything.
As soon as I see expert, I'm doing it.
All right, so for this one, G gets plugged into F. So this 1/4 x squared gets plugged in right there. So it is going to be square root of 1/4 x squared minus 1. And you cannot do anything to that, hands off. Honestly, that's like the biggest battle, is knowing when to actually do something and when to leave it alone. All right, which one's the inside one? G. Does G have a restriction? Great. Step 1 done. Does F have a restriction? Yes, that's where you have to set up a problem. Hey, G of X, which is 1/4 x squared. Hey, G of X, you better what? You better stay greater than or equal to 1. Better stay bigger than 1, or else you have to be this tall to ride the ride. And then you try to work that out. Just, do some algebra. What do you do to cancel out a 1/4? Times 4. You're already done with the problem. Wait for me. Times 4. So that'll give you x squared is greater than or equal to 4. And then good, you square root that and you get plus or minus 2. It looks like this, but it's going to be those little alien antennas, just like the other one that we did, except instead of 3, it's 2. So it'll be negative infinity to negative 2, bracket, union 2 to infinity. And if you want to draw it, you can. You don't have to. I'm just showing you. You do not have to draw this. I'm just showing you what it would look like. It would look like this.
Are all of those gonna end up looking like that?
It will either be like that, or it will be, hey, I'm already complying. Geez, leave me alone. And it'll be all reals, one or the other. It'll either be, hey, like when you try to square root a negative, it didn't work, so we just got all reals. It's either, hey, leave me alone. I'm already following the rule, or it'll be like that. One or the other. All right, this one, F gets plugged into G. So this square root x minus 1 gets plugged in over here. A little bit of canceling is going to happen here. I wrote it out so you could see it, though. If you can do it in your head, I'm okay with that. These cancel, and you'd have one more step. You have to distribute the 1/2 through there. So, oh, because I did a copy error. I am so sorry. That is called a copy error. I am very sorry. I make mistakes too because I am like a human being. Copy error. Excuse me, 1/4 we're going to distribute. So it'll be 1/4 x minus 1/4. Why is it a 1/2? Because I made a mistake.
I was like, what did I mean?
No, I made a copy error. Okay, which one's the inside one? F. Does F have a restriction? That means you keep it. Does the outside one have a restriction?
No.
So you do not need to set up a problem. You simply copy that over. When the inside one has the rule, it's easy. You just copy it over. When the outside one has the rule, that's where you have to do work. As we're starting to get it. The last one on here, I made them both have one. You'll be okay.
Inside copy, outside.
Inside copy, outside problem. Okay. Yeah. Do you mind doing this now since I'm teaching? Okay. Who's your troublemaker for this one? Yeah, -3. I knew what you meant. We'll just do a few more. You're still gonna have tons of time. You have to do a lot of these though. This is like most things in math, it's very practice driven. All right, this is absolute value. What would that look like? V. So it is going to be all reals. Is left and right forever, just like a parabola. So for this one, G gets plugged into F. It's going to look like this. Can you combine the 2 and the 3 and get 5?
No.
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 One is inside the absolute value and one is outside. Just do not. Basically, when you see an absolute value, don't do anything. Don't do anything to this. All right. Inside is G. Does G have a restriction? No. Great. Does the outside one, does F have a restriction? Yes. Okay. So here it is. Hey, G of X, which is this. Hey, G of X, You better not equal -3 or else. This isn't you need to be taller than a certain amount. This is we're kicking out the troublemaker. You better not equal -3 or else. And then you just try to see what happens. So what do you guys know about absolute values? When you absolute value something, it is always positive. So will this ever equal a negative number? No. So you get everything. Again, it's like when your parents are like, clean your room. And like, I already did. Geez, leave me alone. Like you already are in compliance. You already are following the rule. Do you see what I'm saying? An absolute value is never going to be negative. It's already following the rule. We cool? Not sure if that landed. Let's try it the other way. F gets plugged into G. So this entire fraction gets plugged in over here. It's going to look like this. I'm not going to say it because it is kind of wordy, but don't combine them. If you see an absolute value, just don't do anything. Like that is not going to go together. Just leave it alone, which is great because it's no work. All right, which one's inside? F. Does F have a problem? A restriction? Yes, that means we copy it over. Does G have a problem? No. So this is just your answer. Again, it's when the inside one has the restriction that it's easy. You just copy it. All right. If you were like, hey, I didn't quite get that. I made up another one like it. What do you think for F on number 11? Everything except for 7. Good job. And then an absolute value is always. So F of G. G gets plugged into F. It's going to look like this. 1 over... See, I'm not going to say it. Just look. If I try to read that to you, it just sounds like speaking in another language. And then just leave it. That's it. Just don't do anything to it. Does the in good? So you're even saying, I try to say the same things over and over, so you'll have like a spiel of my voice in your head when you go through this. Does the inside one G have a restriction? No. Great. Does F have a restriction? Hey, G of X, which is this, you better not what? You better not equal 7 or else. No dessert.
Wait, why do we change the alligator to that?
Because this isn't like you need to be taller than a certain amount. It isn't like this much or above. It's saying you can't be 7. 7 is our troublemaker that we're kicking out. Now that's actually going to be a problem you can work out. I'm going to show you how it splits. I want to let you know let me know if you remember this from last year. You did do this in algebra 2. You're going to get x plus 4 can't be 7. But you're going to get x plus 4 can't be -7 as well. The reason for that is an absolute value is a distance from 0. Pretend this is the number line and I'm standing on 0. How can I be 7 units away from where I'm at? I can go to 7 or I can go to -7. Okay, they're both 7 units away from 0. An absolute value is a distance from 0. And then you just solve those. So x can't be what? 3? And x can't be -11. When you write your answer, you have to do the smaller one first because it's left to right. So it'll look like this. I'm going to give everyone a chance to write it, and then I'll show you another way you can actually do that if that bothered you or you didn't like that, or you're like, I am being lazy and I don't want to write all that. Watch me point to this. What you can actually do is just kind of think about this until you come up with the numbers that work. Now, 3 is kind of easy because 3 plus 4 is 7, and 7 minus 7 is ding, 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 0. But if you sit there and think about it long enough, you're all really brilliant people. You're in advanced math. I bet you'd come up with -11. Look, -11 plus 4 is -7, but if you absolutely value that, it's 7 minus 7 is... So a lot of people will kind of just sit there and think about it until they come up with the 2 numbers. Do you get what I'm saying? Thanks. You guys are brilliant, so you can do that as well. All right, this one, F gets plugged into G. So this fraction gets plugged in over here, and you will not do anything to it. It will just look like that. Which one's the inside one? F. Does F have a restriction?
Yeah.
Yep. So we are going to copy it over. Does G have a restriction? Nope. So there's no problem that needs to be set up. All right, and then this last one. What is your domain for this guy, for this square root? Well, everything greater than or equal to -2. You want -2 and above, because you can't square root a negative. And then this one is everything except 6. I'm going to do this one first because it's the easier one, okay? I'm going to save the hardest one for last so we can end on that. So I'm going to do this one first because it's the easier one. F gets plugged into G. So this square root gets plugged in over here. And just like with the absolute value with a square root, you can't combine those because the 2 is in the square root and the 6 is outside the square root. So just do nothing. Don't put them together. So which one's the inside one? F. Does F have a restriction? We're going to have to keep that. But hold on, there's more because they both have none of them's all reals this time. They both have a restriction. Does the outside one have a restriction? G.
Yeah.
Yes. Okay, so we have to set up a problem. Hey, f of x, which is this. F of x, you better not what? What's the rule here? You can't be 6. You better not equal 6 or else. And then you just work that out. You say, hey, g of x, you better comply. You cannot equal 6. What would you do to both sides? Start solving it. Square. So x plus 2 not equal to 36. And then there you go. Now, humor me for a second, because if you didn't want to write that out, if you sat there and thought about it long enough, you'd probably come up with it. Watch. 34 plus 2. 36, square root of 36, 6 minus 6, 0. Okay, now don't write this because I'm going to put the wrong answer. If you put this, it's really close, but you forgot something because they both had a restriction. You got to keep this one. So instead of starting at negative infinity, you have to start at -2. So it'll look like that. So you can do what I did and write it that way and then just erase it and fix it if that suits you. That makes me kind of worried you might forget, but it's not that bad.
I just want you to know I'm gonna forget all this.
I want you to know I recorded it so you can always watch it again. Actually, you know what? I just made a snap decision. That's as hard as I would make it. We're going to find f of g for this one, but I won't make you do the domain. I would never put one this hard on a test. If you're interested in seeing it, I'll show it to you, but you know what? I don't want to completely lose everybody. This is as hard as I would make it. Let's still find the f of g, but we'll leave that for today because everybody's tired. You guys are doing a great job hanging in with me, so that's your reward. All right, g gets plugged into f. So this fraction gets plugged in over here. And are we going to combine anything together or no? Leave it alone.